You should have both problems done for the warm-up and checking them with your grading utensil. So we're finding the p-value. So this is one where we still use synthetic division, but we're not going to make it the opposite because we know what p is. And in the first one, we have p of -2. So -2 should have gone in the upper left-hand corner. And then we have x cubed, which has a coefficient of 1, x squared, which has a coefficient of -3, x, which has a coefficient of 1, and then -1 at the end. So we're using our synthetic division skills here. Bringing the first down, and then from here it's multiply and add, multiply and add. So 1 times -2 is -2. -3 plus -2 is -5. Multiply again. -5 times -2 is 10. Now we add, which makes 11. Multiply one more time, which makes -22. And we get a result of -23. And remember, by the remainder theorem, that means that the value of -2, if you were to put it into the equation, equals -23. So we write it as p of -2 equals -23. Moving to the second problem. This time our p-value is 3. Again, whenever it's in the p form, we do not do the opposite. We leave it the same. Now, if I look here, I start with an x to the 4th. So that has a coefficient of 1. But then I'm missing several terms. I should have an x cubed and an x squared. Well, since I don't have these two, that means we've got some zeros we have to put in there for placeholders. Check your paper. Make sure you did that. Then we've got the -x. So that means a -1. And then last but not least, the +1. Bring down your first coefficient, and now again we multiply and add. 1 times 3 is 3. 0 plus 3 is just 3. Now we go 3 times 3, which is 9. Add 0 to that, keeps it 9. 9 times 3 is 27. Adding the -1 to that turns it into a 26. And then we've got 26 times 3. Should have given you 78. Add 1 to that means we have a remainder of 79. By the remainder theorem, that means that p of 3, if I were to plug 3 in, I would get the result of 79. Hopefully you got both answers correct. If not, make sure you've been correcting it as we went along. Here's your homework from the other night. I know it's a little blurry, so I apologize. The first one should have been 34. Going straight down, next was 52. 100. These both were missing x values, so make sure you have your zeros in for placeholders. Going over to the right, we have -44, 16, -39. These problems were like the rectangle problems, where we found the factors of the volume of the rectangle, x plus 1, x plus 2, and 2x plus 3. And this one was x minus 2, x plus 5, and x plus 1. So again, the first thing you do is you take this factor, make it the opposite, and you put it through, and that leaves you with the remaining trinomial. You then factor the remaining trinomial using our Santa hat method, and that gives you the other two factors. Same thing on number 24. Since it was -2, we put it as +2 in here. We get a trinomial. This time it's a little bit easier because the coefficient is 1, our a value. So we're looking for factors of 5 that add up to 6, which is 5 and 1. So remember, there is a difference when your a value is not 1 and when your a value is 1. Today's lesson is actually, for the most part, something we've done already, so hopefully it goes pretty smoothly. We've seen the words finding zeros. We also refer to them, hopefully you remember, as roots, or sometimes the word was just to solve them. So we're back to that skill. The difference here is we won't just have quadratics, which again form the parabola, which had 2 zeros generally. Here we could have more than that. Well, the first thing we're going to do is, again, because it says we're finding zeros, we set each of our factor equal to 0. And then we solve. Now, if we look at the first example, the nice thing is they've already listed the factors out. We've got x plus 2 is one factor, x minus 1 is the second factor, and x minus 3 is the third. Well, if those are the three factors, that means we're going to have 3 zeros. So we take each parenthesis and set it equal to 0. And then we solve each one for x. So in the first one, if it's x plus 2, we know we would subtract 2. So x equals negative 2. In the middle one, x minus 1 equals 0. Well, we would add 1 to both sides, so x equals 1. And then on the third one, since it's minus 3, we know we would add 3. So x is equal to 3. And there's our zeros. So we're going to line them up nice and neat here. The zeros for this polynomial are x equals negative 2, 1, and 3. And those are your three answers. So for this polynomial, that means that's where it would cross the x-axis at those 3 points. Negative 2, 1, and 3. So now you're going to go ahead and try the next one. So take a moment, and when you check with your neighbor, when you're done, compare answers and then unpause this to make sure you got it correct. On this one, we do still have 3 factors. The difference is this first x isn't in a parenthesis. Well, it is still considered a factor. But when we bring it down, it's just simply x equals 0. So whenever you've got an x by itself, you know one of your answers will be 0. We then have x minus 3 equals 0, and x plus 5 equals 0. Well, the first x is already solved for. The second one, we would add 3 to both sides. So x would equal 3. And last but not least, we would subtract 5. So x would equal negative 5. So for your final answer, we have x equals 0, 3, or negative 5. And again, on a graph, that's where those 3 places would cross the x-axis. And we'll be learning to sketch the graphs. Well, in our next part, what happens if they're not already set up to find the zeros? So the first thing, and again, this is what we've done before, is if it's not set up in the problem ready for you to find zeros, you're first going to factor. And again, that's referred to, we've talked about the Santa hat or headphones or grouping. All that means to factor. Once you factor, you then set each of those individual factors, which are the parts in the parentheses, equal to, of course, 0 in order to solve them. Now, when we factor, remember, we're looking for GCF, we're looking for A times C, what factors add up to B. All of those are ways that we factor. So if I look at my first example, we have an x cubed, which we haven't really learned how to factor that, but each of the other 2 terms also have an x, which means there is a GCF. They each have an x, so the first thing I'm going to do is take that x out. Well, if I take an x from x cubed, that means I'm going to have an x squared left, because it's like we subtract 1 from that exponent. The middle term, since it started out as 7x squared, means I'm going to have 7 just 1x. And then in the last term, since it's only an x, if I take it out, all I'm left with is the 18. So now we're going to factor what's inside here. We're going to ignore the x. If you want, you could just simply draw an arrow and bring it straight down, because we don't need it until the very end here. Well, my a value is 1, so this is going to be an easy factoring. So I need factors of 1 times negative 18, which is negative 18, and I want them to add up to negative 7. Well, if this number is a negative, that means one of my factors is positive, one is negative, and it has to add up to negative 7. So if I think about my factors of negative 18, I've got 1 and 18. Well, I can't combine that to 7. 2 and 9. Well, I can make a 7 out of that, so I have to figure out which of those numbers is positive, which is negative. Well, since it has to add up to a negative 7, that means the 9 has to be negative. Now, since this was an x squared, it means I can directly start my parentheses. Remember, we only have to go through grouping if our a value is not a 1. So I have x plus 2, since it's a positive 2, and then x minus 9 for the negative. Now remember, if you flip those parentheses and you wrote x minus 9 and x plus 2, that's fine. And now we set each of those factors equal to 0. So we have x equals 0, since there's no plus or minus there. X plus 2 equals 0. And x minus 9 equals 0. The first one's already been solved for us, x equals 0. The second one, we subtract 2, so x equals negative 2. And the third one, we add 9 for that minus, so x equals 9. So the zeros for this polynomial are x equals 0, negative 2, and 9, which again means that's where it would cross your x-axis, at those 3 points. Now we're going to do the opposite, where they give us the zeros and we have to write the polynomial function. Again, this is something we did before with quadratics. Now we're just dealing it with cubics in this case. So the first thing we're going to do is we're going to plug the zeros into the terms. And then we're going to double distribute, which again we call FOIL a lot. And that will give us our polynomial function. Now remember, when we do the zeros, zeros are always the opposite. So when we put them into the parentheses, we're going to make them the opposite here. So my first cubic polynomial function has zeros of negative 2, 2, and 3. So the first thing we have to do is start by putting them into the parentheses. Well, I know that if my x value is negative 2, that means to get to that, it had to be x plus 2 in equation form, because you would subtract 2 to solve for x. So that means the first parenthesis is x plus 2. Well, the second 0 is a positive 2. Well, in order to solve an equation to get a positive 2, it has to start off as x minus 2. So my second parenthesis will be x minus 2. And the third one, the 0 is x equals 3. So I know that in equation form that had to be x minus 3. So my third parenthesis is x minus 3. Now, to be honest, yes, you could go directly from here to here without this middle ground. I just wanted to show you where we were getting the opposite values from. Well, since we're writing a function, we're going to make this equal to f of x. And now we're going to double distribute. Now, one thing to keep this straight through all of our steps is I'm going to double distribute this part, the end part here. And then that will leave this at the front in order to distribute it at the end. So we're going to FOIL x minus 2 and x minus 3. So we're going to go first x times x, which is x squared, outer x times negative 3, which is negative 3x, inner negative 2 times x is negative 2x, and our last term's negative 2 times negative 3, which is positive 6. So we still have our x plus 2 at the beginning, and we've got this nice long polynomial. Well, after we FOIL, we start looking for our like terms, and that's going to be the negative 3x and negative 2x, which is negative 5x. So now I have a binomial times a trinomial. So what that means is we have to make sure that we take x and we distribute it to every single term in the second parenthesis, and then we come back and we do the same thing with 2. We distribute it to everything in the second parenthesis as well. So we first go x times x squared, which is x cubed, x times negative 5x, so that makes negative 5x squared, and then x times 6, which is positive 6x, and then we go to the second part, and we go 2 times x squared, which is 2x squared, 2 times negative 5x is negative 10x, and then last but not least, we have 2 times 6, which is a positive 12. Well, all that's left at this point is to look for like terms. We have no other x cubes, so I'm going to bring the x cubed down. We have the negative 5x squared, and there is another x squared. I'm going to circle them since they're alike. Well, a negative 5 and a positive 2, it's going to make a negative 3. And remember, when we're adding and subtracting, we do not change our exponents, only when multiplying or dividing. So then I look, I have a 6x and another x, so I'm going to put those together. Well, 6x and a negative 10x, that's going to make a negative 4x. And then at the very end, we have a positive 12. So here is our cubic. Look at your exponent, degree of 3, that's cubic. Our cubic polynomial function written from those zeros. Now we have 2 u-tries, so you're going to work on the first one, check with your neighbor, and then unpause the video in order to see if you did it correctly, and then you're going to move on and do the same thing with number 2. So again, unpause when you're ready to check answers. This time our 3 zeros are 5, negative 5, and 7. Well, the 5, again, means opposite, so x minus 5. The negative 5, that's going to turn into the opposite of x plus 5. And then the last one is 7, and that's going to become x minus 7, because we have to make it the opposite. And since we're writing a function at the very beginning, we do put our f of x equals. Now, to keep everything straight, again, I'm going to take the second 2 trinomials, and double distribute. That's not how you have to do that, but that way we'll know exactly what we're distributing at the end. So I'm going to bring down my x minus 5 because nothing's happening to that. And we FOIL the next two parentheses. X times x, you should have had x squared. X times negative 7, negative 7x. 5 times x is a positive 5x. And then last, 5 times negative 7 is negative 35. Now we look for our like terms. So we have x squared minus 2x minus 35. So check that you got that far. Now we distribute everything in the first parenthesis to everything in the second. So we go x times x squared, which is x cubed. X times negative 2x, you should have had negative 2x squared. And x times negative 35 is negative 35x. Moving on to the second term, that parenthesis, the negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 2x is a positive 10x. Check that. That's an easy mistake to make there. And negative 5 times negative 35 turns into a positive 175. Looking for like terms, there's only one x cubed. There are some x squareds, though, that can be put together. Negative 2 and negative 5 makes negative 7x squared. Negative 35x, positive 10x, makes a negative 25x. And last but not least, our positive 175. Again, this is a function, so remember to put f of x equals at the beginning. And that's what you should have gotten for number 1. Last problem for today. So this time we have zeros 3, 3, and negative 3. So again, we're doing the same steps. We know it should be cubic, which means you should have a degree of 3 at the end. So go ahead and try this, check with a neighbor, and then unpause when you are ready to move on. So our zeros here are 3's. Well, if it's a positive 3, I know that in parentheses it has to be x minus 3, always the opposite. Well, we also have another positive 3, so we write that parenthesis twice, and then the negative 3 turns the last one to the opposite, which makes it a positive 3. Again, my recommendation is to double distribute the second two parentheses. So we bring down the first. So we go x times x, x squared, x times 3, 3x. Negative 3 times x is negative 3x. And our last terms, negative 3 times 3 makes a negative 9. Well, we know we're not doing anything with the first parenthesis yet, so bring it down. Second parenthesis, my middle like terms, well, positive 3 and a negative 3 will cancel. So all I'm left with is x squared minus 9. Well, this time it's a binomial times a binomial, so I'm foiling again. X times x squared, x cubed. X times negative 9, negative 9x. Negative 3 times x squared, negative 3x squared. And negative 3 times negative 9 is positive 27. Now when we write our polynomials, we've been writing them in standard form, and it also asks us to do that in the directions. Standard form, again, is your exponents from highest to lowest, so make sure your final answer is that this function is equal to x cubed minus 3x squared minus 9x plus 27. And that should be your cubic polynomial function.